Okay, so we're officially moving on to quantitative data. Okay, so now we're going to pretty much be talking about the same thing, but now we're talking about displaying and summarizing quantitative as opposed to categorical. Probably going to be using this way more in this course than categorical. It's a big part of our course. Okay. We'll start real simple. We'll start with talking about dot plots, okay? So dot plots are used all the time in our course. We like to make them. They're quick, they're easy, they're very simple to understand and really fast to read what's going on with our data. So it is one of the simplest graphs to construct and interpret, but because of that, it actually is in our favor. So each data value is shown as a dot above its location on a number line. We're going to work through one. We are expected to know how to both create one as well as interpreting them. And dot plots are probably the most common graph that we will use for quantitative data this year. So the first thing that we're going to do is draw a horizontal axis or a number line, and we're going to label it with a variable name. We're then going to scale the axis from the minimum to the maximum value. And finally, we're going to mark a dot above the location on the axis corresponding to each data value. Now, in your packet that I gave you, you should have this problem that's talking about the 2012 U.S. women's soccer team. Okay, the team put on impressive show en route to winning the gold medal at the 2012 Olympics in London. Here are the data in number of goals scored by the team in the 2012 months prior to the 12 months prior to the 2012 Olympics. So here's our numbers. I kind of listed them off for you. Let me just shrink these a bit. Okay. So now I'm going to just go through those steps that were on that last slide. So the first thing I'm going to do is draw that horizontal axis, and I'm going to label it with the variable name. So here's my horizontal axis. My variable name here would, of course, be number of goals scored. Okay. I'm then going to decide a scale to set. So I should start with looking at the minimum and maximum values, and then decide, is there any need to maybe skip over numbers? Can I count by every whole number, or do I count by evens? This would be a case that you're not talking about a ton of numbers here. The minimum 0, the maximum's 14, and certainly I think we have enough room that we can go every whole, and we should go every whole because we have quite enough that are close together to look at what that distribution would look like. So I am going to start at 0 and count every whole number for every tick. And now I'm going to start to mark a dot above the location on the horizontal axis corresponding to each data value. I would recommend maybe like crossing off as you go, as to not to repeat or count more than once. You should also, if you're doing this on a grid, it's usually easier, but if not, you should try to make sure that your dots are always lined up. So here we go. First one was 1, 3, Feel free to work this on your own. Feel free to fast forward through me doing the work once you catch on. there. Okay. And that right there is our dot plot. Not much more to it. The next thing that we want to do is start to talk about how we would describe the distribution of our dot plots or any quantitative variable. Okay, making a graph is not an end. The purpose of a graph is to help us understand the data. So after you make it, you're always going to want to ask yourself, what is it that you're looking at? What do you see? What do you notice? Okay, describe the distribution, examine, analyze the data. So here's a general strategy on how to examine the distribution of a quantitative variable. Okay. So the first thing that we want to do is look for any overall pattern and striking departures from the pattern. We're going to describe the overall pattern in 3 ways. We're talking the shape, the overall shape of the distribution of the graph, the center point of the graph, and finally the spread. We're then going to want to note any individual values that fall outside the overall pattern. We know these as being our outliers, our odd man out, okay? That might be something that happened out of the ordinary, okay? And indeed, we'd want to note them. They could be significant. So in terms of our dot plot that we have of the number of goals scored by the U.S. women's soccer team, there's some things that we will get way more specific in starting with the next video after this one. But just in general, there's some things that we already know that we can say. We definitely have a single peak at 4 here. Okay, so peak at 4. This is, I'm speaking about the overall shape of this. We kind of have this single main cluster here, okay, from 0 to 5 goals. And then we have a kind of a big gap that goes on to get to from 5 all the way to 13 to 14. The main cluster has a long tail to the left, okay, not so much anything on the right. I mean, a long tail, yeah, to the left, okay. If we wanted to kind of, in general, think of what the shape may tell us, the U.S. Women's soccer team would probably have scored between 0 and 5 goals in most games. The 4 would be probably the most common. We would refer to this as our mode, okay? And 13 and 14, those were rare occasions. That could have meant the other team was just not anywhere near competitive as they were, or maybe a star player on another team was out with an injury. In any case, those are kind of odd. The main cluster over here is probably telling us more about the team than these. So that's it for what I have to show you. What I would like you guys to do next is to try the accompanying check your understanding. So you can pause this right now, you can try it, and then you can look at your answers and make sure that they match this. And now we can talk about describing the shape, center, and spread of this distribution. Okay? So the shape of this dot plot for the highway gas mileage for 24 models, 2009 midsize cars, I would say that the shape, we have a peak at 30 miles per gallon. Okay, there's definitely a main cluster of values from 23 to 34. In here is your main cluster. Okay. There is a large gap between 18 and 23. There's another large gap between 34 and 40, and then again at 40 to 48. Okay. Sorry, I accidentally hit the mute button. So where I was with the center. So the center is going to, for now, we're going to, it's the midpoint of our 24 values shown in the graph. So we'll find our midpoint at 28. So what this means is that a typical model year 2009 Okay, so now as far as describing this, the center, so the midpoint of the 25 values shown in the graph is the 13th value if we count from either end. You could go through it or you could just trust me. So the midpoint here is at 3. So what does that number tell us? Is the center is going to be your typical game. So in a typical game during the 2012 season, the U.S. women's soccer team scored about 3 goals. The spread, that's the range. So the data vary from 0 goals to 14 goals. And finally, the outliers. So we already kind of addressed them. The games in which the women's team scored 13 and 14 goals clearly stand out from the overall pattern of the distribution. So we'll label them as possible outliers. Later on, we'll discuss a way to tell if they're definite outliers or not. So at this point, I am done with the first video. You guys can go ahead and try that, check your understanding. We can go through it in class to make sure that you guys are all good with this.